is Marco Varlese, and I'm here today to present you the new project that we started just a few months ago, named Phoebe. Uh, so, without further ado, let's get started. So, I would like you to introduce you to the problem statement first. Why did we think of this project? What did we have in mind? First of all, uh, system level tuning, as you may have experienced yourself or heard from other people in the industry, is a very complex activity. And it's so complex that many times system level tuning requires a wide knowledge and expertise across a variety of different components that are building the system. And sometimes it's not just like how many different components people can understand or aware of, but even how deep that understanding, that skill sets built are for each different component. And this makes this basically creates a huge difficulty in tuning a system to its perfection. The second thought is many times we have all experienced system fail. Systems fail when people are not expecting it, and usually they fail when we are mostly really interested in those systems to work at their best. And basically, when that happens, people do feel a lot of stress because dealing with failure, well, it's very stressful for humans. And by the way, I'm not thinking about, and I'm not talking about your data center getting on fire and millions and millions of dollars going to be burned. No, what I'm talking about is those system failures which are causing your systems to not behave as expected, not behaving properly, causing distress both to you as the person, as the people who are managing those systems, but also causing distress to people that are using those systems as end users. You can imagine, for example, a situation where a web server or a database uh, starts being congested because of too many requests to serve, right? And we have all experienced those situations at different times. Uh, what's mostly crucial for a business is that basically when failures happen, that can cost a lot of money. And again, this is not because your data center went on fire, but because your business is definitely losing money if it's offering a service, if it's offering a transaction-based type of uh, revenue on a service that's being offered, or anything else, something that's not working properly, obviously is costing money to a business. So, what is our vision? Well, our vision is to implement AI capabilities in our SUSE product portfolio so that basically any of the components that are building your software stack can actually take advantage of AI capabilities. And you can imagine, for example, our SUSE Linux Enterprise, as well as our SUSE Manager, and so on. And this is the long-term vision. We came up with few ideas that we wanted to start tackling first, considered a little bit of where most situations and most scenarios could really benefit from AI. Well, the first one uh, is and was the networking stack. The networking stack of Linux is a piece of art, but it's also very complex, and to make things working properly and to work at their best. There are lots of intricacies in the networking stack, and there are lots of tunings, lots of knobs that needs to be finely tuned to get the best out of that stack. Uh, in recent years, there isn't any more just kernel space, but the kernel space networking stack. But there are many components, and they're very, very commonly used these days that sits in user space, that bypass the kernel entirely, that do a lot of, let's call it magic, to make better performance, to achieve better performance. And these create yet another level of difficulty in people that have to manage a system, because they will have to learn. They have to learn new things, which eventually can interact with the kernel space components. And so, said all that, we thought, well, maybe the networking stack, despite being a very complex aspect of a system, and a very complicated aspect of a system, is actually worthwhile to start tackling first. And later on, we said, well, connected to the networking stack, well, there are all new network cards. There are all these smart NICs, and there are also a lot of software-based components which can actually establish in a system flow control rules. Imagine like a flow, which is usually identified by a five tuple rule. So basically, a protocol, source IP, destination, source IP, source port, destination IP, destination port, and all these flows can be mapped specifically to different, for example, different CPUs, or can be programmed such a way that new network cards can handle these flows in particular ways. Long story short, though, these have to be all programmatically done by the user, by the operator. So what if instead we could have self-programmable rules, which can, at different point in time, depending on different factors, which I'm not going to too many details here, depending on the different factors, could be programmed differently, so to adjust to the workloads and to the load of the system. Then there is obviously the memory management subsystem, which can benefit from artificial intelligence capabilities, being where the memory is being allocated, or when, for example, things are read or written to disks, and so on and so forth. The CPU and I/O scheduler is another component of a system which can benefit from AI capabilities. Similarly, the NUMA finitization, as well as the IRQ balancing. And last but not least, we thought about the hypervisors world, where, in many circumstances, AI could help for certain behaviors and for certain aspects of even related to security, which these days are pretty important. So, thinking about the benefits, well, we start thinking about the short-term benefits first, and then the long-term ones, when the whole project would have accomplished a bigger impact on the various different products which are belonging to our SUSE product portfolio. And so the short-term benefits, well, we can definitely think about enhanced system telemetry, because in order for an artificial intelligence engine to work effectively, we do need new information on the system. We do need new eyes to provide us with information on the system. And so, besides the idea of AI and the applicability of AI to the system, well, this work will actually make the system seeing better data coming out of it, and so better insights for an operator. which eventually mean we can get better debugging tools and techniques. We can look at things with different eyes, having at our hands new data, which can provide us with better information. The long-term benefits, well, as I said so far, the final idea, the final goal is to get to a point where our system is auto-tunable and self-healed in case of mistakes or errors. The idea is also that we could provide a green impact. If you imagine a situation where the machines can run not necessarily 100% of the power all the time, but adjust accordingly, knowing what the situation can be or could be considered certain scenarios. And so there is definitely like the possibility to have a positive impact on the CO2 emission, which eventually could also mean we can get to some OPEX reduction by, by reducing the amount of energy that we actually expend to run our systems. Obviously, we are not talking about here of a single machine running in a house. It's definitely not the case of a desktop machine, but it's definitely like thinking about the huge data centers with thousands and thousands of machines, which needs power themselves to actually work, and a lot of power for the aircon to cool the environment down at the right level. So how does Phoebe looks like? Well, first of all, it's a software which has a plugin architecture. So it is composed by a skeleton itself, and can support multiple plugins, like for example the networking plugin, the hypervisor plugin, the CPU IO plugin, which basically offer a specialized implementation of a given problem. So the networking plugin obviously will not take care of, for example, the file system or looking into the telemetry of the file system. That would be taken care of the file system, for example, plugin. This actually helps in many different ways. First of all, helps from a pure software development perspective, because developers who are basically focused on a specific plugin, who have a specific understanding of the system, can provide their best knowledge, their best skill set just by working on that specific plugin. And they do not have to know everything else, right? It offers the way of specialization also from a software development perspective. Second of all, the plugin can actually be loaded at runtime, so you do not have to load the whole system who takes care of tuning every single bit on the system you run. You can imagine, for example, that if you are interested only in getting Phoebe to look after your hypervisor setup, then the only thing that needs to happen is to only load the hypervisor plugin and forget about everything else. This does not just offer better performance of Phoebe at runtime, but also makes sure that you have a much better tunability of the system at hand. So this is the plugin aspect of it. It also provides the possibility to load different models at runtime, different machine learning models. And the models themselves are actually an input to Phoebe, obviously. As I mentioned earlier, Phoebe needs system telemetry in order for it to run and to know what steps to take. And so the system telemetry is another input into Phoebe. And last but not least, the last input is the app behavior settings. There are lots of different parameters which can be passed to Phoebe, and these are done through a JSON file at present. And depending on which settings are changed or how these settings are tuned, Phoebe will have a different approach for example, to the system telemetry, how many times, for example, system telemetry is being considered, or how many times system telemetry is being polled, and which type of, for example, approximation functions you may want to use. So basically, how accurate Phoebe research is going to be. The runtime deployment architecture looks mostly like this picture. Things may differ in certain aspects or some specific aspects, but at a very high level, if you imagine our base OS, our foundation OS, our SUSE Linux Enterprise OS, Phoebe would be just a little part of it. And then we have our own applications, and our customers, partners have your own application which run on our base OS with updates. And these solutions can actually be shipped in various different forms of factor. It could be shipped in RPMs, ISOs. If you imagine, for example, our SUSE Linux Enterprise OS, then you can bundle all these in containers or in VMs, which can then run, for example, on any hypervisor or on Kubernetes in case of containers. And this solution is basically landing on the customer system or customer premise. And this is where really Phoebe needs to operate. This is where you want Phoebe to take care of the systems and runtime to make sure that it can run at its best. The model training can also happen, obviously, at the customer premise, so that basically the model that we provide with the initial set of values can still be better tuned specifically to the workloads that are running. And the interesting part is, depending on which level of agreement and which level of compliance needs to be taken care of, well, the model training part could also be shared with us if you want, so that basically we can remodel our models in development. So basically, take advantage of more data to train our models. But obviously, this last step depends on many legal caveats and many agreements. So this is not necessarily something that has to happen. It's completely optional. So how does the use cases and workloads look like? Well, the interesting part here, and actually the most complex part, is there are plenty of use cases these days, and there are plenty of use cases where Phoebe can and could help. You can imagine the embedded space, the IoT space, automotive, the edge scenario, servers, obviously, and last but not least, desktop to a certain extent. These 4 or 5, that there could be 10 different use cases, are mixed and matched with a variety of workloads. You can imagine file transfer versus web pages, serving versus providing a service like a database, query serving, or people running graphics or CAD or intensive computational operations. So you can imagine a lot of intersection and interaction of variety of the workloads together with the use cases, which create an explosion of the matrix and an explosion of which parameters are better applicable and should be tuned at specific use cases, which is also making even more clear why it is very complicated for human to take care of a system level tuning at its best. There are way too many variables which can change over time, which makes this activity very complicated. So something about Phoebe. This is my idea. This is my view at least. Phoebe has the right to win. It's trying to offer and solve a true customer problem. So it's truly customer centric. It really wants to enhance and implement system telemetry to help our end users, you, our customer partners, and your customers. We want to build a flexible, self-tunable system, which hasn't been done before, and eventually provide you with a data analysis service to you. And again, provide ad hoc AI models. If you remember the slide where there was the last part of the model training feeding back data to us, well, that would really help SUSE making and building better AI models in the long term. Where is Phoebe at this moment? Well, Phoebe started at the very end of 2021. I recall it was mid-November when the project really started taking shape, and it was published on GitHub on the 5th of January. Bear with me, it's still very early days. There is a lot of software development that needs to happen. There is a lot of data that we want to collect to ensure that our models are accurately trained. So there is still a long way to go. We submitted the project to Google Summer of Code, and we have some people interested in it. Something that I'm very proud of and that I'm very excited about, together with Professor Nicola Sciuglio of the University of Twente, we are offering Phoebe as a master thesis project for students to work on, with the intention of really ensuring a better collaboration between academia and industry to build the best possible machine learning approach to solve this issue. Something that we're working on right now is to implement a new model which is called support vector machine algorithm, and that's basically in the pipeline. So if you really want to take a look, you can find Phoebe on GitHub on our SUSE page. I would like to also take some time to recognize few people who have expressed their like about Phoebe, but also they expressed their love for Phoebe by helping out with different things and by offering their help and work. So Anton Smorodowski, who helped us with testing and with some Python related issues. Christian Goll, who took this challenge on board and helped us in cleaning things up and ensuring that it's better configurable by the user and with less hiccups. Dan Cermak, who was really important to me with the setup of a CI/CD pipeline on GitHub. He took care pretty much of all the integration work happened on GitHub. Matthias Hackerman for first of all asking the right questions to me and tough questions as well and being really a very valuable point of contact to ensure that the idea could take shape, and also because it took the chance to create the first package in our open build service for Tumbleweed and Leap. So thank you, Matthias. And last but not least, Shungshi. Shungshi was the first one starting to work on Phoebe together with me. He helped with the lab setup. He helped with pretty much the whole Python data collection stack. So thank you very much, Sean, for doing that. As I said, this is still very early days for Phoebe. So what would be really lovely to see is seeing you contributing with ideas, and why not code to us. It's an open source project, so please feel free to submit issues through GitHub, or submit pull requests through GitHub. Uh, I would truly welcome any input, any feedback. And yes, please get Phoebe, download Phoebe, build it and run it. Let us know what you think, what doesn't work for you. Basically, help us with the real life testing. This would be truly awesome and really needed. Please, last but not least, evangelize our new project, our new intentions here. The more people know about Phoebe, the more people can help us and can contribute and can basically help us shape the new project going forward. So, if you are interested yourself, or if you would like to help with spreading the word, the link to the project is github.com/susi/Phoebe. As you can see it written there. So again, any help on this matter would be really, really appreciated. And with that, I really thank you for attending this session. I hope that you like the project, that you like the idea, and I really look forward to hearing from you with issues, with new features to be implemented, anything that can really help Phoebe making your life better. Thank you. Thank you very much.